Ever wondered how computers learn to recognize your handwriting, filter out spam emails, or predict the price of your dream house? Let me introduce you to supervised learning. Think of it as machine learning with a teacher in the room. Here's the deal. In supervised learning, I feed the computer a bunch of examples, and for each example, I show it the correct answer, kind of like handing in homework and getting it marked right away. Each input, whether it's a photo, a chunk of text, or a row of numbers, comes with a label, basically the answer key. The goal is for the model to study these examples, learn the patterns, and then when I give it new, unseen data, it can predict the right answer all on its own. Supervised learning isn't a one-size-fits-all thing. It actually breaks down into two major flavors, classification and regression. Let's start with classification. That's when I want to predict a category, like whether an email is spam or not spam, if a tumor is benign or malignant, or if a movie review is positive or negative. It's all about sorting stuff into buckets. On the other hand, regression is about predicting numbers. Think guessing the price of a house given its size and location, or forecasting next month's sales numbers. If classification is about picking a team, regression is about guessing the score. Now, how does the computer actually make these predictions? There are a bunch of algorithms, each with its own style. First up is linear regression. It's like drawing the best possible straight line through a cloud of data points to predict a number. Then there's logistic regression, which, despite the name, is great for classification, not just numbers. It figures out the odds of something happening, like whether you'll click on an ad. Decision trees are pretty cool too. They're like a flowchart, asking yes or no questions to lead you down the right path. Support vector machines, or SVMs, are the bouncers at the club. They draw a line between different categories and keep things in order. K-nearest neighbors is another one. It doesn't really learn in the traditional sense. Instead, when it sees something new, it checks out its closest neighbors and takes a vote. Naive Bayes uses probability to make predictions, kind of like rolling the dice, but with math. And random forest? It's a whole squad of decision trees working together to get a more accurate answer. But here's the catch. The magic of supervised learning depends on having lots and lots of labeled data. The more and better examples I can give, the smarter the model gets. But collecting and labeling all that data? It's a huge job. Imagine having to grade millions of homework assignments by hand. That's why you'll often see supervised learning in places where labeled data is easy to come by, like email spam filters or medical diagnostics. Of course, this reliance on labeled data is also a big limitation. For cutting-edge applications or new fields, labeling data can be slow, expensive, and sometimes almost impossible. That's why researchers are always on the lookout for new ways for computers to learn, without needing a teacher for every single example. So next time your inbox automatically sorts out the spam or your favorite app predicts the weather, remember, it all starts with supervised learning and a really, really dedicated teacher.